Hello, welcome to Video 1C. We're still working with some angle topics, and the first one up is angle pair relationships, and pair means two, so we're going to be talking about how two pairs of angles can be related. Our first angle pair we're going to call adjacent. Adjacent angles share a side. And because all sides are rays, we say they share a ray. So let's talk about what the sketch looks like, and if there is a relationship between their measures, we'll put that down as well. For adjacent angles, here's one angle having a vertex and two sides, and then I'm going to put another ray in here so that I've now split the big angle into two smaller angles. These smaller angles, which I'm going to call angle 1 and angle 2, are adjacent angles. Now, there's no really relationship in their measures that holds for all pairs of adjacent angles, and that's where we're going to talk about some specific kinds. The first up would be a pair of complementary angles. Now, angles need not be adjacent to be complementary. I could just say, hey, well, let me tell you what complementary angles are. They add up to 90 degrees. So that's right, add to 90 degrees. Now, I could have an angle sitting over here that's 20 degrees, and then another angle that's 70 degrees that's not adjacent to it. Notice they're not sharing a side. They're separated. They're two separate angles. These would be called complementary or complementary pair of angles. If they're adjacent and they're complementary, then they form this right angle in here, so that if this is 25 degrees, we'd say its complement up here is 65 degrees. So these are adjacent and complementary, but they always add to 90 degrees. Okay, so add to 90 degrees. That's the relationship of their measures. After the complementary angles, we have what's called a linear pair. And it's got that base word line in it. And what a linear pair does is it forms a line. So you've got a pair of angles that when pieced together, actually let's put that sketch over with the sketch, silly Sally. Let's say they form a line. Form a line. It's an adjacent pair of angles that form a line. So we've got one here. We've got them sharing a ray, so a linear pair. They are also adjacent, and they make a line together. Because they make a line, and a line is half of a circle, and a circle is 360 degrees, a linear pair always adds up to 180 degrees because it forms half of this circular rotation right here. So angle 1 and angle 2, the measure of angle 1, notice I'm putting measure in there because I'm talking about not its sketch but its measure. Measure of angle 1 plus the measure of angle 2 will always equal 180 degrees. So a linear pair, by the way, is always supplementary. Supplementary, let's put that off to the side. Supplementary angles, where can I fit that? Let's put, if you could write that on the side of your notes, right? Supplementary, you write the whole word. Angles add to 180. So you might say, well, what's the difference between supplementary angles and a linear pair? The difference is the linear pair, they have to be adjacent to each other. Again, supplementary angles need not be. They could be separated. I could say, here's an angle that's 60 degrees. Here's an angle that's 120 degrees. And I don't have them butting up against each other forming a line, but they are supplementary. So supplementary angles add to 180. Linear pairs are adjacent, forming a line, and add to 180. And my last pair that I'm going to put up here are the vertical angles. Vertical angles, loosely, they kind of look like a pair of scissors. It kind of sounds silly, but a pair of skizzers. So what they'll look like is they crisscross, making an X. And you can kind of picture a pair of scissors opening and closing where the bottom part here is the handle and the top parts are the slicers. And what naturally happens as you open and close those scissors is you get these angles created across from each other, and they are called a vertical pair. So angle 1 and angle 2 are a vertical pair. Angle 3 and angle 4 are also a vertical pair. And you'll notice that when they're across from each other like that, they are congruent or their measures are equal. So for a vertical pair, their measures of those angles across from each other are equal. So if this is 60 degrees, so is this. You'll notice for the vertical pairs, the ones next to each other are what we would call adjacent angles. They're also linear pairs, and they also add up to 180 degrees. So there's lots going on with the picture of the vertical angles. So let's do a couple where we're looking for missing angles. And I'm not going to do the easy ones. I'm not just going to crisscross this and say, hey, this is 40. What's this one? Well, it's 40 because I just told you. So we're going to give you ones with a little bit of a twist to them. What's the measure of angle B? I don't know. But what do I know? I know I've got 209. I know I've got 96, and I know angle B is an angle that will complete a full circular rotation. And a full circle is a 360. When you say you do a 360 when you're kneeboarding, that means you turn around fully. So if you're being pulled behind the boat and you're on a kneeboard and you're able to put the handle behind your back and do a full circle, that's called a 360. So let's say you didn't do a 360. You did 209 and 96, and then you bit the dust, bit the water, I guess, in that case. What angle did you not complete in that rotation? Well, just take your 360, remove the 209, and remove the 96. And I'm not going to do that. You can do the arithmetic for that. Well, what do I have over here? What angle relationship do I have? I have these angles across from each other. What are they called? Vertical. What's their relationship? Their measures are equal. So how am I going to figure out what x is? I'm going to set their measures equal, and I'm going to use my algebra skills to solve this. So I'm going to remove the 2 from both sides, attacking the x. I'm going to divide both sides by 3, and I get x is equal to 20. And again, if you're looking for relationships on a picture, and if they say, hey, what's the relationship between angle 7 and angle 8? You'll say they're complementary. What's the relationship between angle 8 and angle 9? You'd say they're a linear pair. You could even say they're supplementary, but more specifically, they are a linear pair. So you should be able to spot those angle relationships. The other task I want to accomplish in this video is understanding markings in geometric diagrams. So there's lots of markings we use instead of words to tell you some relationships. One of them I've already told you, that when you see this marking right here, it means that, let's go label this AB. Let's go label this CD. This marking right here means that those are perpendicular, and we would say that we can conclude that AB, the line, is perpendicular to, that's our symbol, CD. So we've got a symbol that tells us when things are perpendicular. So when you're doing your worksheet, it's going to ask you, what can you conclude based on the markings? And if you see that little right angle box in there, you're going to conclude that the lines are perpendicular. Another thing that they'll do is they'll mark, maybe you've got something going like this. I'm going to give you 2 bits of info here. Let's call this line L, line M, and line N. Sometimes you can use a single letter as long as you put the word line in front of it. So let's go like this. Suppose I went like this, and like this, and let's call this A, D, and let's call this Q, and this point R, and I'll give you a minute to sketch that out. And then I'm going to put another set of markings like that. There are 2 things you can conclude from the markings I put on this picture. The first one is because I put the same number of dashes on these two segments, that's how we mark that they are congruent or the same measure. If I just had one of them on one and two on the other, even if they look the same, they're not. Maybe one's 5 and one's 5.1 centimeters. But if they have the same number of dashes, they're congruent. So I could conclude that segment AD, notice my notation, that's a segment because it ends. Over here, these were lines because they went forever. I can conclude that segment AD is congruent to, and this is our symbol for congruence, it's an equals with a little squiggle over it, is congruent, which means the same length as QR. That's one thing I can conclude from those markings. I also put these little arrows on here. What does that mean? That's our way of saying that those are parallel. So line L is parallel, and here's our notation for parallel. We draw two little, whoops, that didn't come out very well. We draw two little parallel segments in here. This would be saying that line L is parallel to line N. So let me see what other markings. We need perpendicular, we need congruent with the same number of markings. There's also for angle measures, if you see the same number of arcs in here, it means those angles are congruent. So let's call this W, X, Y, and Z. And let's talk about what I can conclude from those markings. Because I've got one arc and one arc, those are markings, geometric markings for angle congruence. So I would say angle. Can I call it angle X? And the answer is no, because from the last video I said you can only name an angle with a single letter if there's no other angle emanating from that vertex. So if it looks like this, I know exactly if you say, hey, look at what's the measure of angle X? Duh, of course you're going to do that one. But on my picture here, if I said, what's the measure of angle X, you wouldn't really know if I'm talking again about the top angle, the bottom angle, or the whole big thing, because they all share that vertex. So I have to specify, putting the vertex in the middle. Angle WXY would be congruent to angle YXZ. That's what I can conclude from those markings. Now the minute I put another dash in here, even if they look the same, now they're not. If this is 42 maybe degrees, maybe this was 42, maybe it's really close, but they're not the same. So I think that's all the markings that I need to discuss. Your next task is to complete worksheets 1.6 and 1.7. Have a good one.